Gloo Mesh adds powerful multi-cluster capabilities on top of Istio, but the user experience of it is still dead simple. Let's take a look at exactly how it works, both from platform engineering, installing and running Istio perspective, as well as the developer experience of using Gloo Mesh multi-cluster capabilities. We'll start by the installation of Istio. You deploy Istio in both the clusters, just as you normally would. Gloo Mesh comes with an operator that can help you deploy and install and upgrade Istio, or you can deploy Istio in a standard way using Helm charts. Once you deploy Istio, the Istio control plane has the capability to peer with other Istio control planes. So this Istio can speak directly to another Istio instance or multiple Istio instances. So you can scale this to hundreds of clusters if you wanted to. So for this peering capabilities to work, we need an east-west gateway. So we'll deploy an Istio east-west gateway on every single cluster. So we'll put a gateway there and a gateway here. And this gateway is actually a zTunnel based gateway. And what this allows you to do is expose Istio on every single cluster for other Istios to consume. So this Istio can now know the address of this Istio and will route traffic through the zTunnel to get to that control plane endpoint. And this allows these Istios to share service discovery information. So once that's installed, now let's switch gears a little bit and talk about the developer experience of it. So let's say I have an application called foo on cluster 1, on namespace 1, and then bar on cluster 2, namespace 2. If foo wants to talk to bar, then bar needs to expose bar to the other clusters. And they can do that by simply labeling the bar service using a well-known label and call it, say that they want to expose it. So the first label we're going to talk about is called global. If they mark it as global, what that allows you to do from other clusters is to be able to call directly to bar using a Kubernetes hostname. So let's take a look at that. So let's say I mark this service as global. What that will do is this Istio will pick up that change and let this Istio know that it has a new service called bar that's available on cluster 2. And this Istio will generate the right service entry and workload entry objects so that the service discovery information in Istio on this cluster knows how to get to bar. So by marking it as global, a new hostname will be available for foo. And that hostname will be bar.namespace2.mesh.internal. So now if foo wants to talk to bar, if they call bar.namespace2.mesh.internal, so they'll just do http bar.namespace2 internal. The zTunnel on that cluster will pick that up and route traffic directly to bar on this cluster. If this cluster is on a separate network, this traffic will actually traverse that east-west gateway and then get to the destination. This is still end-to-end MTLS. MTLS is initiated on foo side and gets terminated at the pod namespace of bar. Let's say that bar exists on both clusters. So you have bar in namespace 2 on this cluster, as well as bar on namespace 2 on that cluster. So now, if I mark this service as global again, these two Istio-Ds will share that they have the same service so that anyone that's calling it can get intelligent locality load balancing. So now when foo wants to call bar, if they use the same hostname, it will be routed to the closest instance of bar. And there's other load balancing policies you can apply based on how you want to route the traffic. Maybe you want to route it to a specific region or stay in a specific zone, etc. You have those advanced capabilities that are available to you. So if you call this hostname, you get load balance between bar on this cluster and bar on this cluster. But if you call the standard Kubernetes hostname for bar, which is either bar or bar.ns2 or bar.ns2.service.cluster.local, so if you call that, if you just do bar, then that traffic stays local. So anybody that calls bar will always get the bar on that local cluster. But if you call this mesh internal address, you get routed to bar in both destinations. So let's say I want all traffic that's going to bar to also have multi-cluster capabilities. So if I'm not able to change the application foo to use this new host name, but instead I have to provide multi-cluster capabilities to the previous host name, just bar, then all I have to do is change the label to global only. And what that allows you to do is all traffic that's going to bar will also get the same multi-cluster routing capabilities. So this is really powerful when you're migrating workloads, right? When you have bar on this cluster and you're moving bar to other clusters, but you're not able to change the host names that your applications have already hard-coded, then you can use this feature to transparently route traffic to an entirely another cluster. Another cool thing you could do with this, you can actually use global only on this bar and entirely remove this service. So once you're done migrating from one cluster to another, you can move bar from one cluster to another, and all traffic that's previously going to bar will automatically be routed to the closest instance of bar, in whichever cluster that's available. Some of the key features to note here is that every control plane is only sharing information about the global services that are available on that cluster. So the amount of information that's being shared between the clusters is extremely small. That allows us to scale to massive number of clusters. We've tested this for 2,000 clusters with 100 million pods, and this model scales beautifully. And what this also allows you to do from a developer perspective is start building multiple clusters and move workloads between the clusters. You can also do more advanced use cases. For example, let's say that you want to roll out a new version of bar in one of your clusters. So let's say I have 10 clusters, and in one of the clusters, I can have a bar-v2, and I can create Istio's traffic routing policies to send just a subset of that traffic to the canary version of the canary version of the service, depending on whichever cluster it's in. And once that application is running well and I'm satisfied with it, I can either promote it to main bar, or I can just deploy the new version across all the clusters. So yeah, very powerful model. It scales really well. You have a lot of flexibility in how do you want to call it, how do you want to route traffic to it, and be able to attach policies to this host name or the standard Kubernetes host names. One of the other things that we should absolutely cover is observability. Even though traffic is traversing across multiple clusters, you still get end-to-end observability. Every Kubernetes cluster comes with an OTel pipeline. It's gathering the metrics and the traces from that cluster. So we know where a request is initiated, which service initiated the request, which cluster it ended up on. So you know exactly where it's going, even though you're running a service across multiple clusters. And last but not least, from a security perspective, you can write authorization policies that says who's allowed to talk to bar, and apply those same authorization policies across all of your clusters, and not worry about where that service actually lives. So if you say that foo's allowed to talk to bar, but bar's not allowed to talk to foo, you can apply that policy on both clusters, and you can move your workloads between clusters. So yes, so very powerful features. You have a lot of security, observability, and traffic routing policies that are available to you, even though you're routing traffic across multiple clusters. To learn more about Gloo Mesh and its advanced multi-cluster capabilities, visit solo.io.